Hello students, I'm Lakshman Singh Rawat, PGT Chemistry, teaching in the Cambridge International School, Dasura. In this difficult time, our school has taken up the initiative to start the e-learning classes to help you study at home properly. At home, please keep yourself safe and healthy and please study regularly. Welcome to grade 11 students. Students, in this situation of lockdown, CIS Daswa has come out with an innovation to reach out to you through the e-learning classes so that you do not miss out on studies. Children, before we start the chapter, I'll quickly discuss the syllabus of chemistry and the question paper pattern. Higher secondary is the crucial stage because at this juncture, specialized discipline-based, content-oriented courses are introduced. Students opt for chemistry with the purpose of pursuing a career in basic sciences or professional courses like medicine, engineering, technology, etc. Therefore, there is a need to provide learner with a sufficient conceptual background of chemistry which will help them to meet the challenges of academic and professional courses in the later stages of life. Students will have 14 units in chemistry of grade 11th. The first unit, that is unit 1, it is your some basic concept of chemistry that we'll be doing today. Later on we'll be starting with this chapter only. Unit 2 is your structure of atom. Unit 3 is classification of element and periodicity in the properties. Fourth is your chemical bonding and molecular structures. Fifth one is your states of matter, and in states of matter we'll be discussing only gases and liquids. Solid state is in grade 12th, and in unit 6 we'll have the thermodynamics. Unit 7 will be equilibrium, then 8th will be your redox reactions, 9th will be your hydrogen, 10th is your S block. S block, your first group 1 and group 2 will be discussed here. Then in unit 11 we have the P block elements, and in grade 11 the P block element that is discussed is only your group number 13 and 14. Okay, and in organic chemistry we'll be dealing with some basic concept. We'll be discussing the nomenclature and the type of reaction and this type of things, more about the structures of hydrocarbons. Okay, then in hydrocarbon we'll be dealing with alkane, alkene, alkynes, then some reactions of aromatic compounds also, and in the last chapter we'll be discussing about the environmental chemistry. Now if you see the marks here, the first two chapters, some basic concept and structure of atom, it's of 11 marks. Classification is of 4 marks. Then you have the chemical bonding, states of matter, chemical thermodynamics, equilibrium. Together it consists of 21 marks. Then redox reaction, hydrogen, S block, P block together constitute your 16 marks, and the last 3 chapters, that is your organic chemistry, hydrocarbon, that's also part of organic chemistry only, and your environmental chemistry, all of them constitute your organic chemistry. They together makes up the 18 marks. So overall we'll have 70 marks of chemistry. Students, remember that in your question paper the domain that are tested normally is your the remembering and understanding, that is basically the knowledge based and understanding, which will be of 28 marks, and in term of percentage it will be around 40%. Then we have the application based questions, okay, which is a little bit of higher level. The total marks here will be of 21, and in term of percentage 30%. Then the higher cognitive skills are required in your analyzing, evaluating and creating. The marks that we have here is of 21, and it is covering around 30%. Remember, there's no chapter wise weightage, and overall there's no any choice of questions, means there will be no overall choice in questions. However, there are 33% internal choices will be given in all the sections. So students, let us start with chapter 1, that is some basic concept of chemistry. Chemistry deals with the composition, structure and properties of matter, which can be best described and understood in terms of the basic constituent of matter, that is your atoms and molecules. In chemistry, we study the composition, properties and interaction of matter. In fact, we chemists are interested in knowing how the chemical transformation takes place. Some of the branches of chemistry are your inorganic chemistry, which basically deals with the element and the compounds. Then we have the organic chemistry, a part of which one you have studied in great depth also in your carbon compound. This is basically the organic chemistry. So basically we study about the carbon compound in organic chemistry. Then we have the physical chemistry, which involves the application of physical law to the study of chemistry. Then we have analytical chemistry, which deals with the qualitative and quantitative analysis of the substance. Qualitative means when we have to identify, let's say, some of the ions. It can be your sulfate ion, it can be your cations and ions. Okay, so here we'll be dealing, analytical chemistry basically deals with that only. And in terms of the quantitative analysis, when we have to find out the amount of the substances, then we are basically dealing with the analytical chemistry, that is the quantitative analysis. Some other branches of chemistry are your biochemistry, which basically deals with the biochemical processes. Then we have industrial chemistry, which deals with the chemistry in the industries. Then we have nuclear chemistry, which deals with the nuclear reactions. For example, the nuclear fission reaction, which takes place in the atom bomb. Then your nuclear reactors. Then we have fusion reaction, which is basically taking place in the case of the stars, your sun, okay, where we have the nuclear fusion taking place. And then we have the transmutation process, which is under your nuclear chemistry. In addition to this, we have other branches of chemistry also. For example, forensic science, we have earth chemistry, and there are various other branches of chemistry. Nature of matter. You must have been asked in your junior classes, what is matter? In fact, we defined matter as any substances or anything which has got mass and it occupies space. And when we talk about matter particles, there is some kind of attraction between them, and they are always in constant motion. Remember, they are always in constant motion, even in their solid state, where there may not be the translational motion, but there is some kind of motion, which may be your vibratory motion. Matter, in fact, under the normal circumstances, that is under the normal condition of temperature and pressure, it exists in 3 states, that is your solid, liquid and gases. Under the normal condition of temperature and pressure, we have the solid, liquid and gases, and under the extreme range of temperature, we have the plasma state and the Bose-Einstein condensate, that is your BEC. Now, do you know that how we find them in the temperature range? In fact, in the lower range of temperature, in fact, at the lowest range of temperature, you will see the Bose-Einstein condensate, and they are very difficult to obtain the BEC state. Then we have the solid state. As we start moving toward the higher temperature range, we have the solid state, then we have the liquid state, then the gaseous state, and under the extreme condition of temperature, high temperature, very high temperature, we attain the plasma state, which is in the case of the stars and the sun. When we ask about the properties of matter, for solid we say that they've got definite shape, they've got distinct boundaries, they've got fixed volume. In terms of their compressibility, they are least compressible, and they've got very high density. For solid, for liquid, we have got fixed volume, but they don't have the shape. They don't have the fixed shape, in fact, and their compressibility is higher as compared to solid. In terms of the density, it is lower as compared to your solids. Whereas when we move to the gases, then they don't have any shape of their own, nor they have got the fixed volume. Their compressibility, in fact, is the highest because they have a large intermolecular spaces between them, and they've got the least density. Then we have the plasma state, which can be considered as the ionized state of the substances. Then we have the Bose-Einstein constant, where all the substances are in their lowest state of energy. Changing the state of matter. In fact, we know that heat and pressure are the two important factors that changes the state of matter. For example, if we start heating the solid, the intermolecular forces weaken, they start to melt, and we have the liquid state. In the case of liquid state, they can undergo translational motion, they can move from one place to another place, however they cannot leave the surface. Okay, then when they get enough of energy, when the heat is supplied to them, they start converting into the gaseous form, where they don't have any kind of intermolecular forces which will be holding them together. In fact, liquids and gases, where the particles can move from one place to another place, they are called the fluids. Then at extreme high temperature range, when we go on heating the substances, or when we go on heating the gases, we get the plasma state. Now let us see the interconversion of states of matter. Now, what are the factors which will convert, or which will interconvert the states of matter? The heat and pressure. These are the two factors which will cause the interchange of the state of matter. In the figure which is given here, you must be seeing that there are 3 points, which is gas, solid and liquid, and they are all cyclic. That is, they are interconverting to one another. Gas is converting to solid, solid is converting to liquid, and liquid is converting to gas. When the gas converts to solid, we call it as deposition, and that will be when the temperature decreases. And the reverse process is called your sublimation, that is the solid converting to gas directly. There are certain substances which undergo sublimation, that is without undergoing the intermediate state, that is the liquid state. For example, your ammonium chloride is one such example which undergoes sublimation. Then from solid to liquid, when the conversion takes place, it is when the heat is supplied. Okay, and this process is called melting or fusion. The reverse process, when the heat is removed, then we have the freezing taking place, that is the liquid converts to solid. And in the third part, where we have the liquid converting to gas, or the gas converting to liquid, you will notice that when liquid converts to gases, that is done when the heat is supplied, it is called the vaporization process. In the reverse process, when the energy is removed, we get the gas is converting into liquid, and this process is called condensation. Classification at macroscopic or bulk level. On the basis of chemical combustion, at macroscopic or bulk level, matter can be classified as mixture or the pure substances. These two classes of matter can be further subdivided as given in the figure below. Now look at the figure below, which is given here. Matter, if it has constant composition, then we get the pure substance. If it doesn't have the constant composition, then we get the mixture. Okay, so the question says, does it have the constant properties and composition? If it doesn't have, that means if it has variable composition and properties, then it must be a mixture. Then in the case of mixture, if the composition is uniform throughout, if the mixture is uniform throughout, for example salt in water, then we call it as homogeneous mixture. If it is uniform composition, then we get the homogeneous mixture. And if the composition is not uniform throughout, that means the properties are different at different places, then we say that the mixture is your heterogeneous mixture. Okay, now we come to the other side of the figure. Does it have the constant property and composition? If it says yes, then we get pure substances. Now the pure substances, further they can be classified as element or compounds. For example, if it can be simplified chemically, then we call it as compound. And if it cannot be simplified chemically, that means there is no further simple element or substances obtained from the substance, then we call it as element. Let us discuss the chemical classification of matter further. First we'll discuss the mixture, then we'll discuss the pure substances. Okay, what are mixture in fact? If we define mixture, then it can be defined as the substances which are made up of two or more pure substances with variable composition. That means they can have the variable composition. One can be more, another can be less, or it can be in any way that the mixing can take place. And one of the property of the mixture is that they can be separated into their component by some physical method. That means they can be filtered. We can revert back the substances from which the mixture is made. And this physical method of separation can be your filtration, it can be your centrifugation, it can be your fractional distillation. There are various methods by which the mixtures can be separated into their components. Now, the mixture can be further of two types. They can be your homogeneous mixture or they can be heterogeneous mixture based on their miscibility. In the case of homogeneous mixture, the components they mix completely with one another and the composition is uniform throughout. That means you cannot distinguish between the two components. There is no boundary between the two components which mix with one another, or there may be more than two components in fact. Now for example, here sugar solution and air, these are the two examples of your homogeneous mixture. In the case of heterogeneous mixture, the composition is not uniform. Okay, at time we can see the boundaries between the different components. For example, your salt and sugar, if you have turbid water, in that case also it is your heterogeneous mixture. Okay, then the component of mixture can be separated by using some physical methods such as your hand picking filtration, which we have already discussed, crystallization, distillation. These are some of the methods by which we can get the components back again. The another form of classification is your pure substance. In fact, the pure substances have got fixed composition. For example, the copper, gold, okay, water, glucose. These are some of the examples of your pure substances. The pure substances cannot be separated by some physical methods. The further subdivision of your pure substance is your element and compounds. Now how do we define elements? Of course, it is the simplest form of pure substance which cannot be decomposed further, nor we can get a simple substances out of it. An element consists of only one type of atom, and there are around only 118 different type of elements known till now. Then compounds. What are compounds? It is also the pure form of matter which can be formed by combining two or more elements, and this combination takes place in some definite ratio by mass. And remember that the compound they can decompose into its constituent element by some chemical methods. Clear? Now students, this is what we will be discussing for today. The next topic that we will be discussing is your properties of matter and their measurement. So till that time, when we meet again, Please stay at home, stay healthy, stay happy. Goodbye.